Today we're talking about patterns with more than one variable. So we've looked at properties, or we've been using properties to help us understand variables already. We've looked at this one where it states that any number, and we're representing any number with a variable a, any number plus 0 is always going to equal that same number. So I could take any number, add 0 to it, and I get the same exact number. 1 million plus 0 equals 1 million. I can also take any number, which we're representing with the variable b, and multiply that by 1, and that will also equal the same number. Again, 1 million times 1 equals 1 million. Today we're going to look at a different property that we use in math. We're looking at the commutative property of addition. And what the commutative property of addition tells us is that I can add two numbers in any order and get the same answer still. So 2 plus 3 equals 5, but if I flip those around, 3 plus 2 still equals 5. It doesn't matter which order I add them, I still get the same answer. So if 2 plus 3 equals 5 and 3 plus 2 equals 5, then I could also say that 2 plus 3 equals 3 plus 2. All I've done is I've taken the first set of numbers that are being added and flipped them around. Now we can use variables to help us represent the commutative property of addition. So for example, I can replace 2 with an A and replace 3 with the letter B and rewrite the original statement 2 plus 3 equals 3 plus 2. So A is 2 and B is 3. A plus B equals B plus A. I've just taken the first two terms and flipped them around. They should equal each other based on the commutative property of addition. So here's another example, and we can use this even if I'm adding 3 numbers together, or 4 numbers, or 5, or any number of numbers that are being added together. So here I have 1 plus 5 plus 2. Well, that should equal 5 plus 2 plus 1. All I've done is I've taken these 3 numbers that are being added together, and I've kind of mixed them together, or mixed them in a different order, but they're still all being added together. So 1 plus 5 is 6, plus 2 is 8, and I can double check that this side equals 8 as well. 5 plus 2 is 7, plus 1 equals 8. So both sides equal 8. I could represent this relationship using variables. I can replace the 1 with an x, the 5 with a y, and the 2 with a z. Now here I said 1 is x. Here I'm saying 1 is x. 5 is y, 5 is y, and 2 is z, 2 is z. So 1 plus 5 plus 2 equals 5 plus 2 plus 1. I could replace all of that with variables and say x plus y plus z equals y plus z plus x. All I've done is change the order. Now, does this work with subtraction? 3 minus 2 equals 1. 2 minus 3 equals negative 1. So the commutative property only works with addition. It doesn't work with subtraction.